Question 1 is a question about binomial expansion. And we're only really interested in one of the terms that comes out of the expansion, and that's where we produce an x cubed. So that's all we have to find. Let's get to it. We're going to say we have p plus 1 on p times x to the power of 4. We don't need to find every term. We only need to find the one term that we're interested in. All right, so what we know is the 1 on p, let's make it x on p, it just looks a lot nicer, is we need to cube it. So we produce an x cubed, which means the other term in the brackets, the p, is going to be raised to the power of 1, because as you know, the powers always add up to, well, whatever the power of the brackets is. So they add up to 4. And in front of that, we need a combination. It's going to be 4, and it's going to be something. What number do we put there? Well, normally we would start with p to the power of 4, x on p to the power of 0, and it would be 4, 0. And then we would be p to the power of 3, x on p to the power of 1, and it would be 4, 1. And if we go along, we would notice, oh, this is the second last one, and so it's going to be 4C3. Having said that, 4C1 will also work because of the symmetrical nature. I'll put a plus sign there and a plus sign after it. And there we go. We found the term that we want. We've got all the parts. So all we have to do is find out what are the values. Okay, so if you remember Pascal's triangle, the very first and the very last one for C0 is 1. The first and the last are 1. For C4 is 1, and the second one and the second last one is equal to the number of the power. And so for C1 is 4, and for C3 is also 4. And so what we get here is for this term, I don't want to keep working like this. Let's just go, what can we say? X cubed term is, and let's just work with that. So it's going to be 4 times p times x cubed over p cubed. All right, we want the coefficient of x cubed, so, and let's cancel a p. We're going to end up with 4 over p squared times x cubed. Now we know the coefficient, and we're told that the coefficient is 144. Therefore, 4 over p squared is equal to 144. We're dividing by p, we can move it up and multiply by 144 and take the 144 down and divide by it. Or you can like flip both sides and then go and multiply by 4. Whichever way, you end up with p squared is equal to 4 divided by 144. And let's leave it like that because they're both square numbers, and we can find the square root of square numbers. So p is equal to, don't forget, plus or minus when we do a square root, 4 over 144, which of course equals plus or minus 2 over 12. We can simplify that even further, plus or minus 1 on 6. And I think we are done. All right, question 2, let's talk about this question before we try and do it. We have a diagram, it's a curve, and we're told it's a sine wave which has been moved, right? Things have happened to it. But p, q, and r are all constants. So what is the value of p? All right, well, let's just talk about what a normal sine wave does. A normal sine wave starts its period at 0, and then by 2 pi it's finished. And so 0 to pi, let's draw it in. It would go up to 1, it would come back down to pi, go down to -1, and then back up to 2 pi. That's a normal one. So what you can see is all the things that have happened. It's been like doubled along the x-axis. How do you double along the x-axis? How do you expand it by a factor of 2? Well, in the coefficient of what's multiplying by the angle, do we multiply it by 2? No, we do the opposite, and we're going to multiply it by a half, by the reciprocal. And why does that work like that? Well, because when theta is now 4 pi, let's try and get 4 pi, and you multiply it by a half, where do you end up? you end up at 2 pi, right? Which is the end of the sine wave, is at 2 pi. And so when theta is 4 pi now, we're at the end of the sine wave. So that is why that works quite nicely for us. So 4 pi ends up producing inside the sine a 2 pi, and that's when you apply the sine to the angle of 2 pi, you're at the end. All right, so we found Q accidentally. We won't even need to requiring to find it. But what that would do, that would just expand this sine wave so it looks like that. That's putting a half from the Q. But other things have happened. And of course, the other things that have happened, if you find the center line of the sine wave, there it is, you'll notice that the amplitude from the center to the peak, that is what you're multiplying the sine by. Normally it's 1, right? Because it goes from 0 to 1. But now it's actually 3. If you have a look, it goes 1, 2, 3. So it's going up 3. So we're actually multiplying a normal sine wave. If we had a sine wave that was down here, we'd be multiplying it by 3, and then it would go up to an amplitude of 3. So we actually know that P is going to be 3 as well. And the final piece of the puzzle is this plus R. What does that do? Well, adding a number at the end either moves the whole wave up or moves the whole way down if it's negative. We obviously have moved it down. And how far has it moved down? Well, you look at the center line and see where did that end up. And it's moved down 2, and so we actually know that R is -2. And so that is how we can just think about this and find out the values that are in the equation. Right, so we can start working on this equation now. State the value of P. Notice that it's only 1 mark. All right, so if it's only 1 mark, you don't have to show any working out. You can just say, I thought about it, and P is going to equal 3 because P is the amplitude, and that sine wave has an amplitude of 3. All right, easy. State the value of Q. It's only 1 mark as well, and so Q, which is what we discussed before, Q equals 1/2 because it's expanded by a factor of 2 in the horizontal direction along the x-axis. And to do that, we need a factor of 1/2. State the value of R, which we found as well. And the value of R is shifted down, so R is going to be -2. R is -2. And we have done the first 3 parts. Well, we've done every part. It's only 3 marks for that question. Given that it's such a low value question, if you're trying to do really well, and that was a problem for you, you could skip it and come back at the end. On to question 3. AP has a first term of 4, a common difference of D. The sum of the first n terms of the progression is something, show that this. Okay, so what we do know is that A is equal to 4 because A is the first term. We also know the sum of n terms from our formula sheet is equal to n on 2, 2a plus n minus 1 times d. All right, and if we look at that, we'd go, all right, what does it have in there? It has an n, an a, and a d. And what does it have in what we're trying to get to? Well, it has an n and a d. It doesn't have an a, but that's because we know what a is. And we also know the sum. The sum is 5, 8, 6, 3. So we can put it all together and go n on 2 is equal to 2 times a. What was a? A was 4. So it's going to be not equal to n on 2 times, in brackets, 8 plus the n minus 1d. You can see that in what we're trying to get to. So let's just leave it. Let's not even expand it at this point. And that's going to equal 5, 8, 6, 3. Okay, so notice what I did there. I looked at what we're trying to get to, and I identified, hey, that's actually already exists in our equation. So let's just keep it together as one thing. And on the other side, it's like, well, that looks like the equation has been rearranged to equal that. So let's try and do a little rearranging here. So we have n on 2 multiplied by these brackets. Why don't we take it over and multiply both sides by 2 on n? We can take it over, multiply by 2 on n, multiply both sides by 2 on n. It disappears from this first side, and we're going to get n minus 1 times d. It's looking so promising at this point. And we're going to get what are we going to get? 2 times 5, 8, 6, 3. All right, that's pretty easy to do in our head, right? 2 3s are 6, 2 6s are 12, 2 8s 16, 1 makes 17, 2 5s are 10, 1 makes 11. And look, it equals the number that we have up there. N comes down to the other side and is divided into that number. Now we just subtract 8 from both sides, and we will have n minus 1 times d is equal to what they asked us to show, 11,726 divided by n minus 8. Well, it's only 1 mark. Why do we have to do so much for 1 mark? Given that the nth term is something, find the value of n and d, giving the value of d as a fraction. All right, the nth term, let's go. The nth term, term n, is equal to a plus n minus 1 times d. So all I'm doing is going, right, they gave us the nth term, let's get the definition of the nth term. We know it's 1, 3, 1, and we know a is 4. So this turns into, the term is 1, 3, it's not 1, 3, 1, it's 1, 3, 9. 4 plus n minus 1 times d. Okay, so we actually have 2 equations now. You can see above there's an equation and below there's an equation. And we want to try and find out the values of n and d. It actually tells us to find the values of n and d. All right, as it sits, there seems like there's a really nice substitution that's available to us because we have n, and they've left it like this for us. We have n minus 1 times d. Why don't we take that and just substitute it right in where we see n minus 1 times d. It seems like is what they would like us to do. Maybe it's the easiest way to do it as well. Ooh, that 4 could have gone over and subtracted from 139. Oh, let's not do it. Okay, we'll do it later. We're going to add, instead of that, we're going to put 11,726 over n minus 8. And we've got one equation, one unknown. Surely we can find out what n is. So 4 minus 8 is negative 4. And if we take negative 4 over, we add it to 131. It's not 131. Why do I keep saying that? And it's going to be 143 is equal to 11,726 divided by n. So n comes over. It's now above, and the 143 goes down, and it's on the bottom of the fraction. Okay, this should turn into a whole number because n has to be a whole number. So we put it in our calculator and we end up with 82. That's great. All right, so how do we find a? We go back to, no, we already know a. How do we find d? We go back to one of the easiest equations. Maybe this one is the easiest equation. I'm going to label it now. I'm going to call it 1. And I'm going to say, let's put n into equation 1 and see what happens. So we've got 139 is equal to 4 plus n minus 1. Well, we can do that. 82 minus 1 is just 80. 81, it's not 80, times d. Why is it so complicated? All right, so we're adding 4. This time we subtract 4, and we'll get 81d is equal to 135, right? And so d is equal to 135 divided by 81. Let's put it in our calculator, see if it simplifies at all. And we get 5 on 3, so that's actually a lot simpler. Right, so let's write our answers and the way they wanted us to do that. So we go, therefore, n is 82 and d is equal to 5 on 3. That's the second part, part B, completed. Right, so the curve with the equation something, it's a quadratic, is translated by -1, 3. All right, so we need to understand what these words mean. Translated means it's shifted, right? And it's shifted by an X amount and by a Y amount. And so what it means is that it's going to go -1 in the X direction. The whole the whole graph, the whole equation is going to move one unit in the negative x, and it's going to move 3 units in the positive y. Right, so how do we do that, and what do we do? So that's the good questions, right? We look at the equation and we say y is equal to, well, what happens with the x? When we shift by -1, we actually add 1. We do the opposite. And so we're going to have x plus 1 and squared. So wherever we have an x, we're going to replace it with x plus 1 minus 5. Why does that happen like that? So that it's x plus 1. Well, maybe this will be instructive on why that happens like that. We're going to shift the y value by 3. So whatever function we have, if we add 3, that shifts the whole function up by 3, right? Yeah, you might be going, yeah, that makes a lot of sense, right? But what if that 3 wasn't here anymore? What if that 3 was taken over to the other side? So instead of plus 3, it came over, and when it's next to the y, it becomes minus 3. And if you look at that, go, oh, look, it's next to the y, and we're subtracting it now. That's a bit weird, isn't it? And maybe that will help you understand that if it's on the same side of the equation as the variable, we're going to do the opposite of what you would think. But when it's on the other side of the equal sign, we do exactly what you would think. We would add the 3, but we can't get the 1 away from the x because it's kind of trapped inside other things. It's in the squared bracket, and it's in a bracket that's being multiplied by something, so we have to do the opposite. All right, so we will just leave the y change on this side and say plus 3. Well, there we have it. That's the answer, but we just have to change it into the form that they asked us for. So it's just expand and rearrange. Let's get to it. Y is equal to x squared plus 2x plus 1 plus 2x plus 2. And we've got minus 5 plus 3 is just minus 2, right? All right, so what have we got here? We should be finished now. We've got x squared. We've got a 2x plus a 2x makes a 4x. And we've got a 1 plus a 2 minus a 2 is just a 1. And we are done. Moving on to part B. We have a curve again. It's the same equation. It's transformed to a different equation and describe a single transformation that has been applied. So there's only one thing that has happened here. And we need to go, well, what has happened? So what would be extremely useful is if we can if we can do something to the original equation to make it look like that equation. And so what can we do? So the only things that we want to transform are the x squared and the 2x. How can I turn x squared into 4x squared? And doing the same thing, turn 2x into 4x. So if I multiply by 2, actually, if we multiply the x variable by 2, it works out very nicely, doesn't it? Because it becomes squared. All right, so instead of x, we would just say, why don't we write 2x? And so we'll have 2x squared plus 2 times 2x minus 5. And what we have there is the original equation, but we've replaced x with 2x. What does that do when you multiply the x by a number? That's a dilation along the x-axis, or a dilation from the y-axis, whichever way you want to say it. And how does it work with the x variable again? It does the inverse, so it's actually going to be a half of what the function was. So it's going to dilate the function by a half along the x-axis. Or, in other words, we could say dilate the function by a half. What will we do? From the y-axis or along the x-axis? I don't know what they like. We'll go from the y-axis. And we could write by a factor of a half. That may even be better. All right, question 5. Having done a few of these, it looks like a disguised quadratic, right? So how do we transform this so it's more workable? Well, we want to get rid of the variable, the root of y on the bottom of the fraction. And the way we would do that is we multiply by root of y. So technically, you wouldn't normally write this, but I'm going to write it for explanations. We're going to multiply the left side of the equation by root y. And we're also going to multiply the right side of the equation by square root of y. And that's the basic of all, the basic idea of all maths. What you do to one side of the equal sign, you do to the other side. Of course, on the left side, we're using distributive law, and the y gets distributed to every term, well, the root of y. And on the right side, it will just become 0. All right, so let's distribute the y. We got root y times 6 root y. When you have root y times root of y, you just end up with y. We're going to multiply 2 over root y. The root y will cancel. We're left with 2. And then minus 7 times the square root of y equals 0. Okay, so it is a quadratic. Let's rearrange it so it looks, maybe you can see that it's a quadratic. If we go back to 6 root y and we square it, you see, oh, there's the squared term, is the root y. And then minus 7 times root y, and then plus 2 equals 0. All right, you can see pretty clearly that if we replace the square root of y with x, you go, oh, that's a quadratic, 6x squared minus 7x plus 2. So if you want to replace it, you can, or we can just work with it like this. Can we factorize by inspection? What multiplies to 12 and adds to negative 7? Oh, that would be 3 and 4, right? Negative 3 and 4. So let's do that. 6, root y. I'm leaving it like this. Oh, there's so much to leave. Minus 3 root y minus 4 root y, because they multiply to 12, plus 2 equals 0. Let's take out a 3 and a square root of y, and we'll be left with a 2 root y minus 1. And over here, let's take out a negative 2, and we would be left with 2 root y minus 1, because we took a negative 2 out of 2. That leaves us with negative 1. And finally, the last step we get, well, it's not really the last step. It is a step along the way. We'll get 3 root y minus 2 multiplied by 2 root y minus 1 equals 0. All right. Therefore, either bracket is 0. For the first one to be 0, the square root of y has to equal 2 over 3. If it's 2 over 3, then the whole bracket is 0. Or for the second one, the square root of y is going to equal 1/2, because half of 2 is 1, and 1 minus 1 is 0. And to find y, we just square now. So y is going to equal 2 squared, which is 4, 3 squared is 9, or y is going to equal 1 squared is 1, and 2 squared is 4. And we're done. In part B, if you look at that, hopefully you would notice that that is just the equation we just solved, except for where there is a 10x, we had a y. And so to actually solve this, we go, well, we solved it where there was a y there, which means the 10x is going to equal the solution. So from the previous question, we know that the 10 of x is equal to 4 on 9, or the 10 of x is equal to 1/4, right? Okay, perfect. So that's all we're solving is just a trig function now. X is the inverse 10 of 4 on 9, or x is the inverse 10 of 1/4. What you should notice is we need to go between 0 and 360, so we got to look at all quadrants. And I guess that's the only trick, is it? All right, let's explain what we're doing then. X is equal to the inverse 10 of 4 on 9, which you can do on your calculator. Make sure you're in degrees mode. Or x is equal to the inverse 10 of a quarter. So if we do the inverse tan of 4 on 9, we get x is equal to 23.96. Well, ask on the front of the paper to round to 1 decimal place. The 6 makes the 9 go up to the next one. So actually, it's going to be 24.0 degrees. And remember, we are in degrees mode, not in radians mode. And there is another answer because that's the first quadrant, which means there's another answer in the third quadrant. So we add 180 degrees to our 24, and we'll get 204.0 degrees to 1 decimal place. And for a quarter, we're going to get, better start writing a little smaller, x is equal to 14.0 degrees. But we need another answer in the third quadrant, so we add it to 180, and we'll get 1x is 194.0 degrees. Just slipped it in. Question 6, they give us a quadratic, and they're pretty much telling us to complete the square on this quadratic. And so let's do that. All right, so to complete the square, we need an x squared without a coefficient in front of it. So we need to factorize the 2 out, and we need the second term as well. And so we're going to end up with minus 8x. All right, the third term, or the constant, doesn't get involved in completing the square, so it gets to sit out there on its own. And once we're in this point where we've got the x squared with the 1 in front of it, we can say, well, what's half of b? And square it. And then we add it on, right? But you can't just magically change things. So whatever we add on, we also have to subtract. So in this case, we take a half of b, and we're going to get -4, and we're going to square it and add it on. All right, I like to write it like that because it shows me what goes into the next step. Right, but we can't, as I said, just add things on. It changes the equation. So if we add something, we also have to subtract it. And when I do the subtraction, I like to go, well, let's work it out. And so -4 squared is 16, positive 16, of course. And so we want to subtract 16 so that we haven't changed anything. It's still the same equation. Okay, now there's something tricky that happens here. This 2, if we expanded the brackets, remember it would multiply by every term inside the brackets to expand it, which means that 16 or the -16 can actually come out of the brackets. If we multiply it by the 2 out the front, it will be as though we expanded it out. And so we are definitely going to do that. So let's do that. And let's do the first part first. The 3 terms that we have here now are a perfect square. So we can complete the square on that. And we will get x minus 4, which is why I left it in the -4 form. And the whole brackets is squared, right? The 2 still stays out the front. And remember that 2 multiplied by the -16 to be able to make it come out of the brackets. And so that becomes -32 plus 23, and we're almost done. So we just have to add 2 numbers together. I said 2, so I started writing 2. 23 minus 32 is -9. And so we're done. We should write that x is less than 3 as well. Express the function in the form. We've done that. We don't technically have to say what a and b are. It's obvious from the form. Part B, we have to find the range. They give us the domain, x is less than 3. And so how do we find the domain? All right, we need to analyze this, and in our head, we do a little sketch. What's going on with this quadratic? We know that it's a smiley quadratic because out in front of the x squared is a positive number. So that means it's going to be a smiley quadratic, right? And we know the turning point because it's in turning point form, which is what we completed the square to do. And to find turning point form, you ask yourself, well, what x value makes the bracket 0? And of course, the x value is 4. So if we go to 4, that's the x value of the turning point. Where's the y value of the turning point? Well, it's what is hanging out after the brackets, -9. And so for -9, we should write -9 here, not to scale, of course. And so we know that it's going to look like this, right? We know that pretty quickly. This is only 1 mark, so You're meant to be able to solve this without too much trouble. And we're also told for the domain that x is less than 3. So wherever 3 is, here's 3. X is less than that. So let's put a line there and go, well, they're the only valid values for the domain. So now we know this. If we find this point on the function, well, the range is going to be all the y values above that point. And that's it. That's how we solve this question. So we say, what is the value of the function when x is 3? And we'll get 2 times 3 minus 4 is -1, and -1 squared is just +1, minus 9, and we'll get -7. Okay, so that is the point. And we know that y is going to be larger than that point. Therefore, well, let's write it over here. Therefore, the range is y is larger than -7. Right, so find the expression for the inverse of the function f. All right, so remember for the inverse, the y becomes the x becomes the y, and it's as if the whole graph was mirrored in the line y equals x, which of course means that the range of the function becomes the domain of the inverse, and the domain of the function becomes the range of the inverse. So that's kind of helpful when we write our answer. So to do this, I like to just do a variable swap right at the front and go, let's change the x and y around. And so y is what the function is, and let's turn that into 2, and now x becomes y, -4 squared minus 9. So we take the 9 over and add it to x and then divide by 2, and we'll get y -4 squared is equal to x plus 9 over 2. Okay, so now we're going to do a square root, and it raises the immediate question, do we do the positive and negative, or just the positive and just the negative? All right, so if we remember back to the function, it was 3 and -7 is where it started, and it looked something like that. Yeah, that's the function f. And when we do the inverse, remember the inverse is a reflection in the line y equals x. So if you imagine the line y equals x, there it is, and we did a reflection in that line. That's actually quite hard to try and imagine that for me. So what I'm going to do, I'm going to continue the quadratic, because it was a quadratic, right? And I'm just going to put some dots there and go, oh, there's the turning point at 4, -9. So when that gets reflected, the parabola is going to turn onto the side, and instead of being at 4, -9, the new turning point is going to be at -9 on the x and 4 on the y. So it's going to be there, and the parabola will be on the side like this. Okay, so, and then if we went to 3 on the y, on the x, and that's the reflection, is the bottom part of that. So let's get rid of that. All right, so that's what the graph is meant to look like, and what we'll know, and of course x is going to be larger than -7, and y, if you look at the y values, they're all negative, which tells us when we get to do the square root that we want the minus. We don't want to add, because as x gets larger, the square root is going to get larger, but we don't want it to get too large. So we have y -4 is equal to the square root of x plus 9 over 2, and we actually only want the negative version, because as you look at the graph, you would say, oh, as x gets larger, y is negative, and so we want the negative answer. And so our answer becomes y is equal to 4 minus the square root of x plus 9 over 2. Let's write it with the notation they like. The inverse function is equal to 4 minus the square root. I'm just keeping it like this. There's no real nice way to simplify that. And the range that we had before becomes the domain. So x is now larger than -7. I think we're done. On to part D. They give us the function g, and they say find and simplify an expression for f, g, x. So g gets put into f. So here's the function f, and we're going to take the function g and put it in. So where we see an x, we're going to replace it with 2x plus 4. And that's it. We should pay some attention to the domains and ranges and make sure everything works out. But at the moment, we're just going to trust that it works out. Is that okay? So we get 2x plus 4. Oh, look, minus 4. Squared minus 9. That's quite nice. Let's have a quick look at the domain and range for g. And what do they tell us is x is less than -1. So when we put that into the equation for g, -1, we're going to be, what does it turn out to be? 2 times -1 is -2, plus 4 is +2. And then as x gets more negative, just the whole function is going to get more negative. And so the range for g is going to be less than 2. And we look at the domain for f, we go, it's less than 3. Oh yeah, it works, right? Because all the range values for g actually work in f. So, you know, this is working out for us. All right, so we've got 4 plus 4 minus 4. We're going to square 2x, and we're going to get 2 times 4x squared minus 9. All right, 2 times 4 is 8. We'll get 8x squared minus 9. I think that's as simple as we can make it. All right, question 7. We have this big diagram. There's a circle. We have the equation of the circle, and we have a line which goes from the y-axis, 0, 2, cuts the y-axis at 2, and goes to the center of the circle. Let's find out what we need to do. The point B and the line segment BC intersects the circle at P. Okay, we see that. Find the equation of BC. Well, BC is a straight line, so we're just finding the equation of a straight line. What do we know? Well, we know one end, B. Do we know the other end, C? Well, of course we do. The other end is the center of the circle. So we look at the equation of the circle, and to find the center, we go, all right, what x value makes the bracket 0? And the x value is 2. What y value makes that bracket 0? The y value is -4. And that is the center of the circle. And point B is 0, 2. We have 2 points. We just have to find the equation between 2 points, and that is the equation BC. And if you're not sure, you can always check, does 2, -4 make sense on the diagram? It makes a lot of sense. 2 on the x, -4 on the y. So you should be very confident at this point. How do we find the equation between 2 points? Well, we find the gradient first. The gradient is the change in the y divided by the change in the x. So let's take y. Let's take -4 minus 2 divided by 2 minus 0. And we're going to get -6 divided by 2 is just -3. Okay, does that make sense as well? Look at the diagram. Is it possible for the line BC to have a gradient of -3? Well, yes, that's imminently possible. Do we know the value of C for this equation? Yeah, we actually know the y-intercept. Of course, it's the point B. Who knew it was going to be so easy? The y-intercept is 2. Therefore, the line, we have all the information we need. BC is y is equal to -3x plus 2. We're done. Hence, find the coordinates of P. Give your answer in exact form. To find P, we're finding the intersection of the line and the circle. And how do we solve any 2 equations? Well, they're simultaneous equations. We're going to either use substitution or elimination. In this case, when you have squared variables, you always are doing substitution. So we're going to substitute the line into the circle equation, and we will get x minus 2 squared plus, instead of y, we're going to write -3x plus 2 plus 4 squared equals 20, and we have a single variable x, which we should be able to solve, right? We just got to expand, turn it into a quadratic, and then solve it. And that's the plan, right? So the first brackets, we better expand. X squared minus 4x plus 4. And for the second brackets, well, the 2 plus the 4 makes 6. So we really have negative 3x plus 6. So we get negative 3x squared will become 9x squared. The negatives become a positive. We've got 2 times negative 3, which is negative 6, times 6, which is negative 36. Negative 36x. You can write more if it helps. And we've got 6 squared, which is going to be positive 36. And let's bring the 20 over and subtract it. And finally, it equals 0. Okay, so we've got x squared plus 9x squared will become 10x squared. We have a negative 4x minus 36x minus 40x. Isn't that nice? And we have got negative 4 plus 36 minus 20. So it turns into, no, that's not right. It's positive 4. 4 plus 36 is 40, and 40 minus 20 is 20. What? Let's divide both sides of this equation by 10. X squared minus 4x plus 2 equals 0. Can we factorize that by inspection? What multiplies to 2 and adds to negative 1 and adds to negative 4? No, nothing. Like 2 and 1 multiply to 2. They don't add to negative 4, which means let's flip to the quadratic formula. X is equal to negative b. I may as well write it. Plus or minus the square root of b squared minus 4ac. Oh, that's why they said exact values, because they knew there were going to be square roots, over 2a. Okay, negative b, we get 4 plus or minus the square root. B squared becomes 16. And we're going to subtract 4 times 1 times 2. 4 2s are 8, minus 8, so that's going to be root 8 over 2a, which is 2. Okay, so what do we get? We get x. Let's keep writing x. X is equal to root 8. Root 8 as a surd simplifies to root 4 times root 2, and root 4 becomes 2. So we'll write it out. 4 plus or minus 2 root 2 over 2. I did that because we can divide the 2 in now and get x is 4 plus or minus, not 4, 2. Plus or minus root 2. Okay, but, you should definitely think and remember back to the diagram. Yeah, here's the diagram. There's only one answer for the intersection, which is P. And imagine if that line extended, well, there would be the second answer. But we're not extending to that line, so the only valid answer is the smaller x value, right? See, the smaller x value. Larger x value. So we use that knowledge of our brains thinking about what's happening, and we identify, why did I write n? Because I said n. All right, let's just go for the point P, x is equal to, well, what's the smaller value? It has to be the minus, 2 minus root 2, and that is our x value. How do we find the y value? Well, to find any y value, well, if you find any other variable in simultaneous equations, you need to put the variable back in to one of the equations, and you would choose the simpler equation for sure. So we're going to choose the y is equal to negative 3x plus 2. So y is negative 3, 2 minus root 2, that's the x, and plus 2. That was our equation, right? All right, we just got to simplify that as much as we can, and we will get y is equal to negative 6 plus 3 root 2 plus 2. And normally we write the third second, so we get negative 6 plus 2. We've got negative 4 plus 3 root 2. Okay, therefore we now know the point. Point P is, the x value is 2 minus root 2, and the y value, negative 4 plus 3 root 2. We're done. All right, so we have a nice diagram here with a curve, a horizontal straight line. A and B points are indicated, and the equation of the curve is indicated. And they tell us all of this. The straight line is y equals 5. But we worked that out, hopefully, when we looked at the points A and B. Find the equation of the tangent to the curve at the point A. All right, so to find the equation of a tangent is always the same. Find the gradient of the curve. So we need to do the derivative to find the gradient of the curve at A. Use the gradient and the point to find the equation of the line, which is the tangent. And that's it. So we're going to differentiate the function, going to put 1 in, x equals 1, and then we're going to use the point 1,5 to and the gradient to find what we need. All right, so the hardest part, is it the hardest part? We're going to differentiate the function. All right, let's write it. Y is equal to x to the half. They even wrote it in a nice form for us to differentiate to the minus a half. So dy dx, hopefully we are good at this by now. The power comes out the front, multiplies by the whole term, and we subtract 1, and we have negative root x. We're going to add, oh, it's going to be minus now. Of course, we get negative a half or times 4. It's negative 2x to the negative, subtract 1, becomes negative 3 on 2. Okay, to find the gradient, that's what we're doing. So when x equals 1, of course at point A, the x value is 1. Then dy dx is going to equal a half times. All right, so we're doing the square root of 1. Remember, when you have a negative power, that turns into a positive power when it becomes at the bottom of a fraction, and it's to the half, so it's going to be square root of x. That's what it's really doing. But when you put 1 in for x, you do square root of 1, you get 1, and when you divide 1 by 1, you get 1. And so the answer is just a half, and hopefully we can work that out. And for the second part, well, it's going to be the same thing. We've got 2, and the x would come down. It would be root x cubed. And so 1 cubed is 1, square root of 1 is 1, and 1 divided by 1 is 1. And so everything, so 1 to any power, we can probably say is just 1. And so what we have here for the gradient is a half minus 2. 2 is 4 on 2. And so 1 minus 4, negative 3 on 2 is the gradient. All right, that's the gradient of the tangent, remember? And we also know a point for the tangent, and the point is 1,5. So how do we find the equation of the tangent? Ooh, someone in my class likes to do this. Y minus y1 is equal to mx minus x1. All right, technically that's the answer. We've written an equation, and you know, that's it. That's nice. That's the equation of the tangent. But you know, if you wanted to, you could rearrange that, and we could say y is equal, let's expand brackets, minus 3 on 2x plus 3 on 2, and the 5 comes over, and we add 5. And of course, 5 is 10 on 2, and 3 on 2 plus 10 on 2 is 13 on 2. Hey, we could multiply both sides by 2 and get 2y is negative 3x plus 10. And isn't that a nice way of writing it? Actually, there isn't even a nicer way of writing it. And that's 2y plus 3x equals 10. Look, you didn't have to do that. You could have stopped at right where we were and say, take the marks right then. Calculate the area of the shaded region. Let's go back to the diagram. Right, so the area of the shaded region, we can find the area under a curve by doing the integration. So to find the shaded region, we want to find the area of the rectangle. Yeah, that's a rectangle. And then subtract the area under the curve. So the area under the curve is that. And that will give us the shaded region, right? So we don't have to integrate one function minus another function. We can be smarter about this and say, well, what's the area of the triangle? Well, x goes from 1 to 16, which means that's 15. And it's 5 high. 5 high. So it's not, did I say triangle? It's a rectangle. Area of the rectangle is 75, right? And so we can actually just do that and then do the integration of the function from 1 to 16. Okay, so we should try and make it clear to whoever is marking it what we're doing. We're going to do the area is, okay, the whole rectangle, which was what, 5 times 15 minus the area under the line, which is the integral from 1 to 15, 1 to 16, right? yeah, 1 to 16 of x to the half plus 4x to the negative a half. And of course, it's with respect to x. Don't forget, you need that dx. All right, so we have the area is 75 minus, let's do some integrating. The x, we are going to add 1, and so we'll get x to the 3 on 2. We need to get rid of it, so put a 2 on 3 out the front. This one, the x is going to go up to a half, so we add 1. It goes from negative half to positive a half. That half, when we differentiate, the half would come out the front, and so we have to multiply by 2 to get rid of it. So we're going to have 8, and that would turn it back into the 4. If we differentiated the 8x to the half, we would get back to 4x to the minus a half. It's always good to check what you're doing. So now we're going to put in 16 and 1, and we're pretty close to finishing, right? So we get 75 minus, okay, it's going to be x square root of x cubed, and so square root of 16 is 4, and 4 cubed is 64. So we have 2 on 3 times 64, and we've got plus the square root of 16, and the square root of 16 was 4, right? And then we're subtracting 1. Well, we learned before that when you do 1 to any power, you just get 1. So we have that. So at this point, we can just put it into a calculator and come up with the answer. We've shown enough steps there to get the marks. So that's good. Good job. Right, question 9. We have a sector of a circle with a triangle inside of it, and they give us an angle. In the triangle, it's an isosceles triangle. You see two sides, which are both 6 centimeters. The arc CD is part of a circle with center A. All right, so what we know is the radius of this circle is AC, and it's also AD. We don't actually know the radius, but it would be handy if we did. Find the perimeter of the shaded region. All right, it definitely is handy, because we need the radius to be able to find the curve of the arc. We already know this length is 6, and if we have the radius, we can find that by the radius minus the 6 is equal to dB, right? So radius is extremely important in making progress. So remember, AC is the radius. We have a triangle, isosceles triangle there. Can we work out AC? You bet we can. It is called the cosine rule. C squared is A squared plus B squared minus 2AB cos of C. Okay, let's work on this. So that's AC, right? AC squared. Actually, let's not call it AC. Let's call it the radius. The radius squared is equal to 6 squared plus 6 squared minus 2 times 6 times 6 times the cos of 1.8 radians. Well, put your calculator into radians mode and enter it in. All right, so we get r squared equals 88.358. All right, 36. On it goes forever. So r is the square root, and that's going to be round about 9 point. It's going to be around about 9.40. Okay, because this number is irrational, the decimal goes on forever. Don't use 9.4, store the number in your calculator and use the stored number whenever you need to use the radius. Okay, what else do we need? We need the angle at the sector of the, at the center of the sector. So how do we find that? Well, it's isosceles triangle. Remember, we have a 6 and a 6. And so what we know is these two angles are the same. Let's call it theta. So the angle at the center is theta. So we know 2 theta plus 1.8 radians is a triangle, and that's 180 degrees, but we're not in degrees, we're in radians. 180 degrees is pi. So we can work out theta. 2 theta plus 1.8 is equal to pi. 2 theta, pi minus 1.8, and theta is pi minus 1.8 divided by 2. So that's the angle at the center. Pi minus 1.8 divided by 2. Right, so let's make some more progress. We need the arc length. Yeah. How are we going to do that? The arc length from our formula sheet is equal to radius times the angle. And the radius, it's approximately 9.4, but we're not using that. And the angle at the center was pi minus 1.8 divided by 2. If we put that into a calculator, using the exact values, we're going to get round about 6.31. Right, so we're almost done now. The perimeter is going to equal the arc length, 6.31 approximately, plus the 6 we have along one side of the triangle, plus the radius, which is 9.4 minus the 6 on the other side. And that, when we put into a calculator, is 15.7. Let's check units. The units are centimeters. And we found the perimeter of the shaded region. Right, to find the area of the shaded region, we're going to do the area of a sector minus the area of a triangle. All right, for the area of the sector, we know that's going to be, from our formula sheet, if you don't know, half r squared theta. And for the area of the triangle, we know two sides and the angle between it. So we can go a half AB, they're the two sides, and sine of the angle between them. Okay, let's fill in the details. So the radius that we worked out was around about 9.4, but we've got that stored on our calculator, remember? And the angle, if we work that out, the pi minus 1.8 divided by 2 turned into something like 0.6708. I've actually stored that on my calculator as well, so I have the exact angle at the center of the circle there. And then we're going to subtract a half of 6 times 6, the two sides of the triangle, and the angle between those two sides is the 1.8. Okay, if we use the exact values, we put the angle in the triangle, we'll come up with the area. And that will be, let's go approximately, 12.1 centimeters squared. Done. Right, we get given a function, fx, and we're told to integrate from 1 to infinity of the function. All right, technically you shouldn't be allowed to use infinity like a number, but they're doing it, and so we'll just continue with the way that they're approaching this question. So we're going to go 1 to infinity of the function, and the function is 4x plus 2 to the power of negative 2 with respect to the x. All right, how do we integrate? It's a chain rule. All right, so we're integrating with the chain rule. So the brackets would stay the same, and the minus 2 would have come from minus 1. We add 1 when we integrate, don't forget. All right, so now we start thinking, what happens if we differentiated this? Well, a 4 would come out of the brackets. Is there a 4? No, there isn't. So we need to get rid of the 4 that would come out by putting a quarter in front. And the negative 1 would also come down and make it negative. Is it negative? No. So we need to multiply by negative 1 as well. And that finishes the integration. And we're going from 1 to infinity. Hopefully we're not getting too scared by this. What shall we do? We'll put the values in. I don't like using this. All right, anything to the power of negative 1, of course, we can make it a positive power by put it on the denominator. And so we end up with negative 1 divided by 4 times infinity plus 2. This just feels so wrong. And we're going to subtract negative 1. So that means we're adding, and we get rid of that minus 1. We have 4 times in brackets we put 1 in for x. So 1 times 4 is 4, plus 2 is 6. So we're going to have 4 times 6. Okay. So at this point, we look at the first fraction there and we go, you know what? The bottom is infinity. Because if you multiply infinity by 4, you get infinity. If you add 2, you're at infinity. Multiply by 4 again, you're at infinity. Infinity is not really a number. It's a concept. So we're dividing by infinity. And of course, anything divided by infinity results in 0. Okay, we can say that, but what we really mean is as the bottom of a fraction gets larger and larger and larger, the result of the fraction becomes smaller and smaller and smaller. So as you approach infinity, the whole fraction approaches 0. So if we could get to infinity, we would get to 0. So this becomes 0 plus 1 on 6 fours are 24. That's our answer, 1 on 24. Right, so the question is done, and we really should do it that way because that's the way they gave it to us. But if you're going to be mathematically maybe better at presenting things, you would do this. You would say, what is the limit as k approaches infinity of the integral from 1 to k? And then we would just do the whole thing with a k. 4x plus 2 minus 2 dx. So eventually we would get to this same point, but instead of writing infinity, we would say we're still looking at what's the limit as k goes to infinity of, and let's go to the second line there, 1 over 4 times 4k plus 2 plus 1 on 24. All right, if we got to that point, we would then say, all right, so as k goes to infinity, that whole fraction goes to 0, and you end up with 1 on 24. That would be the better way. I've left a few steps out, maybe, but that's the better way of presenting it. Right, so we're told a point's moving along the curve of the function that we know in such a way that as it passes through some point A, its y-coordinate is decreasing at a rate of k units per second, and its x-coordinate is increasing at a rate of k units per second. Okay, we can take that information and form two rates of change. The change in y, change in time, is equal to negative k because it's decreasing at k. And the change in x at the change in time is equal to, this is per second, is equal to a positive k. All right, so at this point we go, hey, I've got related rates. They both have a dt in there. So it is possible for me to find dy dx, right? Because dy dx is going to equal dy dt times dt dx. And so in that case, dy dt is negative k, and we're going to multiply it by dt dx is 1 on k, which is equal to, oh, well, you know, we get negative 1. So what this tells us is that the gradient is negative 1 at this point A. So let's go back to the function. The function is y is equal to 4x plus 2 to the power of minus 2. And let's go, well, let's find the derivative and then make it equal to negative 1. So dy dx. It's a chain rule. We differentiate 4x plus 2 and we get a 4. The 2 comes down, we multiply by the negative 2, and we're also going to multiply by, leave the brackets the same, subtract 1, we get negative 3. And so that is, let's simplify it a little bit. We're not going to simplify it a lot. Negative 8, 4x plus 2 to the negative 3. Right, so at point A, the derivative is negative 1. So why don't you write this? Point A, we know that negative 8, 4x plus 2 to the negative 3 is negative 1. Okay, let's multiply both sides by negative 1 and take the brackets up to the other side. We'll get 8 is equal to 4x plus 2 to the power of 3. Now remember that to the power of negative 3 means it's on the denominator. So it's effectively a fraction, negative 8 over the whole brackets cubed, which means we can bring the whole brackets cubed up and multiply it on the other side. And we have the positive indice there. Okay, so this doesn't look too hard anymore. We've got 4x plus 2. Let's find the cube root of 8. We get 2. And so 4x is equal to 2 minus 2, which is 0. And so x equals 0. And to find y, we put x back into the equation. So y is equal to 4 times 0 plus 2 to the negative 2, which means 4 times 0 is 0. So we have 2 to the power of negative 2. Negative 2, it means that it's 2 over 2 squared, which is a quarter. And so our point A is x is 0 and y is a quarter. Okay, can't fit much more on. Right, question 11, the point P lies on a line with the equation y equals mx plus c. It's just a standard line. M and c are positive. Oh, positive constants. Look, it tells us something. A curve has the equation y equals negative m on x. We're going to assume that's the same m. There is a single point P on the curve such that the straight line is a tangent to the curve at P. Find the coordinates of P, giving the y coordinate in terms of m. Okay, we don't really have numbers to work with. We're going to have to work with the two equations they gave us. Y equals mx plus c and y equals negative m over x. The only thing we really know is it's a tangent, and what we know about tangents is they touch the line once. Also, we know that the gradient of the line is going to equal the gradient of the tangent. So there could be a couple of ways we can solve this. If we go with a tangent only intersects the line once, right? It doesn't intersect the curve more than once. We could probably do that. So we're looking to say, well, what are the intersection of the line and the equation, and how can we see that there's only one of those intersections? Let's try it out. Y equals mx plus c and the curve y equals negative m on x. All right, it seems quite obvious. We can just equate the two together. So we'll get mx plus c is negative m over x. Okay, we're looking for where this has only one solution for x. And of course, it's a quadratic. Let's multiply both sides by x. And we get mx squared plus cx is equal to negative m. Or in other words, mx squared plus cx plus m equals 0. Okay, so it is a quadratic, but we only want one point of intersection. And we can check to find when there is only one point of intersection, when the discriminant is, or the determinant is 0. All right, the determinant is b squared minus 4ac. Okay, so we're going to make b squared minus 4ac equal to 0. So b squared is c squared minus 4 times m times m. A is m and c is m. And that has to equal 0 for there to be only one point of intersection. Okay, so what have we got here? We have got c squared is 4m squared. C squared is 4m. So we can do the square root of both sides. The square root of c squared is c. The square root of 4 is 2, and the square root of m squared is m. So that tells us that c is equal to 2m. Right, so what have we exactly done here? We said here's a quadratic we're trying to solve, which is giving us the point of intersection, the coordinates of P. If we can solve that, we'll get the x coordinate of P. And we said, well, there can only be one x coordinate. We can't have two different values, otherwise it's not a tangent. And it came to this condition where c equals 2m, which is kind of good, because if you have a look and you said, oh, look, if we replace c with the 2m, that's going to be beneficial. Because if we replace the c with the 2m, there's an m in every term. And we'll see what happens then. It can be factorized out, right? Plus 2mx plus m equals 0. So let's factorize the m out, and we'll get m times x squared plus 2x plus 1 equals 0. So the brackets must equal 0. And this is a perfect square, as you would expect. x plus 1 squared equals 0, and therefore x equals 1. Actually, it doesn't equal 1, it equals -1. Therefore, x is equal to -1. So we found the x value of p, and we want to find the y value. We'll go back to either of the original equations and go, how do we find the y value? Well, let's go to the second one. Y equals -m divided by x. And so y is -m divided by -1, which is just going to turn into m. That's always how. So point P is going to have the coordinates of -1 and m. In these exams, of course, you have to show you're working out to get the answer, so that would be how we do it. Part B, the normal to the curve at P, same point, intersects the curve again at Q, another point. Find the coordinates of Q in terms of m. Okay, so this is, we do the same thing that we would normally do. We have the equation of the tangent. If you remember, the equation of the tangent was y equals mx plus c, but we found out that c was 2m. All right, so that's the equation of the tangent, and the point, we just worked out the point as well at P, which was -1 and m. Okay, so given that, we can find the equation of the normal. So the perpendicular gradient, perpendicular m, is equal to the inverse negative of the gradient, and the gradient is just m. So the perpendicular gradient is -1 on m. The point is -1 and m. How do we find the equation of the line? Let's use y minus y1. Y minus y1 is equal to m, -1 on m, x minus x1. Oh, x plus 1. All right, so that's the equation of the normal. And we want to find where it intersects the line, so we need to intersect it with the curve again. And the curve, if we can think back, was -m on x. So y -m on x. We have to find the intersection of these two equations. All right, let's simplify the line first. Maybe that will make life easier. Y is equal to -1 on mx minus 1 on m plus m. Right, so we have two equations, and we want to know where they intersect each other. And so we're going to do what we do. We solve the equations simultaneously. So we have y equals something else. So let's put them together, and we're going to have negative mx is equal to -1 on mx. Let's put these two together, and so we're going to have m can turn into m squared on m, and then we'll have m squared minus 1 over m, and we're adding because the minus sign went with the 1 there. Okay, that's handy. So we want to get rid of the x on the denominator. Let's multiply everything by x. Multiply both sides by x, which means we multiply every term by x. We get -1 on mx squared plus m squared minus 1 on mx. We rearrange. Let's take everything over to the left. -1 on mx squared plus, no, it's actually going to be minus. Right. The reason we took it over was to get rid of that minus sign. And the next term would become negative m squared minus 1. Actually, we can make that 1 minus m squared and make it positive. Don't worry about it at the moment. And we still have the minus m, and that equals 0. Okay, so we have a quadratic that we're trying to solve. But we actually know something. We know that one of the points is P, and the other point is Q. And for point P, we actually know the x solution. And the x solution is -1. And so the factor is x plus 1, because then when x is -1, it makes it 0. Okay, so if we know that, the rest should all just fall in place. What do you multiply 1 by to get -m? Well, you multiply it by negative m, so there needs to be a negative m in the other brackets. And what do you multiply x by to get 1 on mx squared? Well, you multiply it by 1 on mx. And that should equal the middle term, given that this line actually does go through P, and P is on both the curve and the line. It's a solution for both, right? When x is negative 1. Let's check. So you probably wouldn't check normally, but I want to. And the only thing we really need to check is what makes the x term, those two things together. Okay, so we have 1 on mx minus mx, which of course is m squared on m, which becomes 1 minus m squared on mx. Is that the same? Well, yes, it is, because if we multiply it by, now if we do negative, negative, if we do a negative, negative, so, if we multiply it by negative 1 twice, right, you haven't changed anything. So we can make a negative, negative, and that would change the inside of the brackets to m squared minus 1, which is what we have at the top. Okay, so it did work, just satisfying the curiosity of our work. Right, so the point Q has to be the other bracket, and so we know that the brackets equal 0, so 1 on mx minus m equals 0, or 1 on mx equals m, and x is equal to m squared. Okay, how do we find the y out? Well, we want to put it into either the line or the equation. The line is complicated. Let's put it into the curve. So the curve is just negative m on x. And so we will get y is negative m over m squared. Well, that should simplify. I think we can drop an m to be negative 1 over m, which then tells me the coordinates for P, no, it's not P, point, it's Q. Point Q has got coordinates where x is m squared and y is negative 1 over m. And we've finished.